Welcome to this session. This session, we are going to solve a problem on continuity of function of two variables, x and y. So here's the problem. Test for continuity of the function f of xy given by xy, x squared minus y squared divided by x squared plus y squared if xy is not the origin and 0 if xy is the origin. Now, there are three things for us to test. First is to show that the function is well defined at the origin. 2 is to show that the value of the function has a limit as we approach the origin. 3, show that the value of the function at the origin is the same as the value of the limit. So, solution. The first thing, you see that f at 0, 0, according to this function, the answer is 0. Because they have told us that when x, y is 0, 0, then the value of the function is 0, or the formula defining the f of xy is 0. So f of 0, 0 is well defined. So the first test for continuity has been satisfied. Let's see the second condition on the limit. Now limit x approaches 0, y approaches 0. Now we use the first function, first formula, xy into x squared minus y squared divided by x squared plus y squared. So there are 4 things for us to test. The first thing, step 1, we start by x equals to 0, followed by y equals to 0. So we write this as limit y approaches 0, and then limit x approaches 0, xy, x squared minus y squared over x squared plus y squared. Now, when you replace 0, we'll have limit y approaches 0. So 0 times y, 0 squared minus y squared over 0 squared plus y squared. The whole of the numerator will be 0. So 0 over y squared, and limit as y approaches 0 of 0 is 0. So we call this one f1. Step 2, we let y to be 0, then x equals to 0. So simply we reverse the steps we have taken in 1. i.e., the limit as x approaches 0 into limit y approaches 0, xy into x squared minus y squared divided by x squared plus y squared. So which will be limit x approaches 0. Now would be x times 0, x squared minus 0 squared divided by x squared plus 0 squared. I'm simply replacing y for 0 here. So numerator will be 0 because 0 times this bracket. So we'll have limit x approaches 0, 0 over x squared, which is limit as x approaches 0 of 0, which is 0. So we call this one f2. Now, since f1 equals to f2 equals to 0, we go to step 3. Step 3 is when you replace y for mx. So approaching the origin through the line y equals to mx. So step 3, put y equals to mx and then find the limit. It will be limit xy x squared minus y squared, x approaches 0, y approaches 0, x squared plus y squared will now be limit as x approaches 0. So where this y you put to mx, so it will be x into mx, and then x squared minus mx squared divided by x squared plus mx squared. So the function now will be purely in terms of x. So we'll have limit x approaches 0. This will give us mx squared into x squared minus m squared x squared. Here I can factor out x squared, and I have 1 plus m squared. I hope you can see how this results into this. So that this and this cancels out. And then we have limit x approaches 0 of m into x squared minus m squared x squared divided by 1 plus m squared. Now here direct substitution will work. Where this x put 0, so it'll be m into 0 squared minus m squared times 0 squared divided by 1 plus m squared. You see here we'll get 0 times m, which is 0, over 1 plus m squared, and this will be 0. So this is the value for our f3. Also, since f1 equals to f2 equals to f3 equals to 0, then we go to step 4, the last step. Step 4. Step 4 is whereby you approach the origin through the parabola y equals to mx squared. So step 4, put y equals to m x squared, i.e. a limit x approaching 0, y approaching 0, xy x squared minus y squared divided by x squared plus y squared will be limit. Now we'll only have x, and then here we have y m x squared minus mx squared divided by x squared plus mx squared squared. I'm simply replacing mx squared for y in this function here. So on simplification, we'll have limit x approaches 0. Now here I can say x power 3, x power 2, and then I have mx into x squared minus m squared x power 4, I'm opening here, divided by, I factor out x squared in the denominator. So I'll have 1 plus m, this will be m squared x power 4, because I've factored out x squared, so I remain with x squared here. Now with this factorization, I'll cancel the x squared, which are factored outside the brackets. So this and this cancels out. So we'll have limit x approaches 0, mx into x squared minus m squared x power 4 divided by 1 plus m squared x squared. Now in this case, we just use direct substitution to get the limit. So this will be m times 0 into 0 squared minus m squared 0 power 4 divided by 1 plus m squared 0 power 2. Because 0 times this bracket, so we'll have 0, and then here we have just 1. 0 over 1 is 0, so this is our f4. Now since f1 equals to f2 equals to f3 equals to f4 equals to 0, then limit of the function exists, of the given function, exists, and we conclude that limit of f of x, y, x approaches 0, y approaches 0, equals to 0. So second property of test for continuity is satisfied. And then we conclude, since f of 0, 0 equals to 0, and this is the same as limit of the function as x approaches 0, y approaches 0, then the function f of x comma y given is continuous at the point 0, 0. So therefore, for this given example, the function is continuous. So that's how we solve that problem.